Greetings, everybody. Cody Rogers back at it again. Get ready to dive deep into the Darlington pair version of my Dusk to Dawn circuit. Before I did the non-Darlington pair, when I thought I was doing the Darlington pair, but now we'll actually do the Darlington pair version. We'll be analyzing its current behavior with the trusty PPK2, and it's gonna get wild. Well, as wild as it ever gets here. This evaluation is extra special since I did manage to capture some bizarre current graphs while simulating the low light conditions. So that was when I put my hands over the photo resistor, and then it sort of gets some dips and skips around a bit. Very fun. Always I'll have those handy dandy chapters in the description of the video. So if you're eager to jump around to a specific measurement or want to see the graphs, and that's really all you want to see, feel free to use those chapters and skip around. But trust me, you will want to stick around for the whole ride because it is going to be very fun. Thank you. Hello, so I just want to go over my calculations for what I expect to find with the PPK2 and other methods that I may use, mainly my multimeter to measure the voltages at the different points of the transistors and why I got there. So first we go to J4, which as you can see is the one that goes through the 68 kilo ohm resistor and down into the Q5 and Q6 transistors there, and it sort of sets the current that goes through that sink or mirror, and that current is 35 microamps. So basically, since it's given 35 microamps through, it forces Q6 to give the same or close to it. Yeah, and then J2, I just said 35 microamps because it's basically remarking on the same there. J5, where's J5? Ah, there it is. J5 is the base current coming from Q9, which turns on the LED. And I said in the light, I expect it to have 0 milliamps. And then in extreme cases, like when it's really pitch black out, it will be very close to J3. And J3 will be close to N2. Because then there will be basically no current flowing through J7, which is right up there. Which, yeah, so J6, that's the current through the LED. As you can see, I just said it's, I've calculated the current going through the resistor based on saying, well, there's a 0.6 volt drop from the transistors and a 1.7 volt drop on the LED, which means there's 0.7 volts going through the resistor, which comes out to be about a milliamp. J7 in the dark, Q3 effectively turns off because the photoresistor resistance goes way up to like 300k or something. So then there's almost no voltage seen at Q3. J7 in the light, I said about 35 microamps, which is the same that goes through J4, since it basically hogs the current while, because this will be turned on so greatly, like it's gonna have I think something like 2.5 volts at its base, where this one here just has 1.5 volts, and it always will have 1.5 volts. Then J1 current, that's all the currents And I just added them up in the light and in the dark. Okay, now we are going to basically do everything we just did, but with this one, which is the one I had actually earlier analyzed on my whiteboard. And then I went and I decided to measure the stuff of the other one. Which, I don't know if I mentioned it. The main difference between this one and the other one is the other one doesn't use Darlington pair, and this one uses a Darlington pair. So now we're measuring J1, which is the total current going through the battery. Just let it settle here again. Yeah, so I will put it at, let's say 241 microamps. Because it bounces up a little bit back and forth. I would almost think there might be an oscillation here. Just because it is bouncing up back and forth a little bit. So now let's turn off the lights and we should see a big spike. And we do. Goes up to above 1.5 milliamps. But we are falling quite drastically. Yeah, we're going to call it at 1.37 here. I'm just going to take a quick look at my whiteboard. Yeah, no, it's higher than what I had calculated the first time. The first time I made my calculations, I actually had calculated slightly higher values than I settled on, because I forgot about the current setting would be going through, like there'd be one diode drop through that one of the transistors. But here, let's go and measure that one through the current setting. So the current going through this guy here, so it'll be going in there and out through there. So we connect our V in to this one and our V out over here to this one. There we go. That's all connected. And we are reading about, right about what I thought we should have, which I thought we should have 35 microamps. We're reading like 34 microamps, effectively. 33.86 microamps is the average right now. I'm going to put down 34. So now, yeah, I guess I jumped the gun there a bit. I'm going to measure this too, because the value in the dark really should not change, because it is just set by that 68 kilo ohm resistor. So, but we will see. Turn off the lights, and it does change a slight bit. See, it will. Yeah, so it's enough to change what I put down. I'll probably put down 33 now. So it changed by a microamp. My dog is looking at me very confused as to why do you keep on turning on and off the lights? Silly human. Okay. So now that we've done that one, we shall continue on to day 2, which is the current going through the other side of the current mirror. Right there, that guy. So unplug that. You see, we tend to read some nanoamps when it's just sitting there loosely. Pop that off. So we are reading, I would say that's going to be like, yeah, 35 microamps. Nope, it's going to go up now. And we're still charging up. Holy. Sorry, I went over to play with my dog for a second. It does look like we have averaged out to 37 microamps. So that is going through. I think it's day 2. Yeah. So now let's turn the lights off. Again, it shouldn't change, but yeah, we've seen that before. It goes down in voltage. Or in not volt, in amperage. Yeah, so now I think we can safely say it's done falling. So we'll put 36 microamps, which is, yeah, a microamp less than before. Turn the light on. So now we will go and do the current that goes through the 2 transistors that are turned on and off by the photoresistor. Is this guy right there? Right there. Go like this. So I want to just mark on the current going through when day 7 when it is somewhat dark. So the way I'm going to do that, I think I just answered my question though. I'm going to try and turn the LED on while not seeing such a drastic decrease in the whatchamacallit, in the current. We'll go like this. Yeah, so now we see we're angling it down. Now we go, yeah. The more I cover with my hand, the more it angles itself down. You see, when I turn, yeah, so it basically, when I have my, when I've covered it enough that it hits that a certain point there, that it turns that LED on. See, the LED is on a bit here. Let's see what if we can hold it there. Oh yeah, we can. It's very hard though. So I would say that we're at about 5 microamps. there. I just wanted, that was like sort of a side quest I gave myself. If it is somewhat light, almost dark but not quite, I said J7 should have some current. The mark on both J7, which is the one we were just covering and the one we're measuring right now, and J3, which is the current through the other side of the, like the other two transistors that form the comparator. So it was J7 had about 5 microamps through it at that time. Anyways, that was just sort of a side quest I wanted to give myself. Now we will find where it lands here. So I'd say it's at about 37 microamps. Like it's 36.88, but we're not doing the points for the microamps. That's J7 here. Now, let's turn the lights off. So when we slam right to 0. Okay. Let's turn them back on. And now we will go to the non-photoresistor side of the current, which is that J3 I was talking about. Unplug those. Plug this in. And the light will turn on again because we'll give a temporary path to ground. So you see now we are reading 0. But again, let's do that side quest. I try to turn the LED on. Yeah, it looks like we can have it on at about 30 microamps. If I let... Okay, we're at like 25 now. So, I'll say 25 30 microamps. That's just when it's sort of dark, but not that dark out. So it's, yeah, again, like when it's sort of dark, or, but not dark out. Which one are we looking at? J3. So in the light, it is 0, effectively. And then in the dark, let's turn it on. Basically, we'll bounce right up to 35 microamps or thereabouts, I bet. But we shall see right away. Oh, and look at that. It's at 34.9 microamps. I'll just wait and see, because it's climbing right now. Maybe we'll level off at 36. So, yeah. I would say that it leveled off around 36. So let's just throw that in there. Turn this on. So next will be current going through J5. Again, remember, since the PNP resistor, it goes out, current goes out of the base, not in. Which determines how we hook that up. So we're at 0. And I bet, let's just see. Can I coax it into being the light again? Oh yeah, I can. So I'll just remark IJ, what is this, 5? And 5 to 30 microamps. Just like where it's in that odd situation that I'm just kind of covering it with my hand. Now, we'll see what it is in the dark. So I would say we are safe to put down 35 microamps already. Doesn't seem like it's moving around too much. Okay, now we will do the current through the LED. Okay, let's see. We do have some nanoamps going through. Let's see what happens when I go have it almost on. So it looks to me like it's either on or off, and it's just making some buzzes. Now it's bouncing around so much. We'll put down the average 0.16 microamps. Let's turn the light off. We should bounce up. Yep, we went right up to just over a milliamp, but it looks like 1.15 milliamps or so. Let's see. But we will be falling, yeah. So yeah, I would say that we're at about 1.09 milliamps. Okay, let's turn the lights back on. Just look at how close I got. So for the overall current, I was a bit low in my estimations. For the set currents, I was within a microamp, which I don't think is all that bad. And then with the current going through the two transistor sides, I was pretty close, and my sort of assumptions or expectations of what would happen when I tried to mimic, like, almost dark but not quite dark, was also pretty close. Then my expectations of current going through or coming out of the bases of the PNP resistors was correct, as was the current going through the LED, other than like a not quite a microamp, like 0.16 microamps go through the LED even when it is off, which I wasn't expecting. And then when the LED's on, it was actually pulling 0.9 milliamps more than I expected. But other than that, I was fairly correct. So that's a wrap. I hope that you enjoyed watching me go through this particular circuit with all these test points right here. But don't fret. There is another installment in this evaluation series, which is already at like an hour video. But there's another installment where I am going to put a test point here, one here, and another one here. And that will be very exciting, I think. And I hope that you stay tuned for that one. And you better hit the subscribe button and the notification bell so that you will be one of the first to hear about when that episode drops. Thank you so much for watching, and see you next time.